They think they know the cold. But this winter, it doesn't just bite, it breaks men. Let them come! I want to see the look on their faces when the frost finally takes...
The fabric of reality is not static. Now, observe the entanglement! I am the rewritten code.
You guys have been asking for a video covering the LTX 2.3 version 1.1 update, specifically a 1080p image-to-video workflow that actually runs on an 8GB VRAM setup and supports LoRAs. In this video, I'm going to walk you through exactly that, but honestly, we need to get a quick disclaimer out of the way first. Look, LTX 2.3 is still pretty rough when it comes to temporal consistency, which basically means it really struggles to preserve the fine details of your original image. And if you caught my last video and thought LTX 2.3 was bad at text-to-video, image-to-video might just drive you crazy. It is incredibly tough to get decent, consistent results, even when you pair it up with LoRAs. So when we're talking about local image-to-video generation, WAN 2.2 still holds the edge for overall quality. Take a look here. You can clearly see the subject's original facial identity, right down to the eye color, has completely changed, and those scars totally vanished. You can spot this exact same issue glaringly in this generation as well. Now sure, you can use LoRAs to patch up the visual style, but that underlying problem with facial identity, it remains a massive headache for LTX 2.3's image-to-video capabilities. And it's not just faces either. The model seriously struggles to lock down other crucial details. Just check out this clip.
Pardon me, is the guest network experiencing a heavy load today? My cloud synchronization is running a bit behind schedule.
Sorry about that.
It's quite busy this morning. I'll check the router settings for you right away.
In the source image, we clearly have a guy, but hit play on the video, and suddenly he's transformed into a girl. And whatever these two were originally drinking, that morphed into something else entirely. So, with all these glaring issues, what can we actually use this model for? Well, here are a few clips you can manage to generate without running into too many roadblocks, and without even needing any LoRAs. Check these out.
Even in the deepest shadows of the old wood, the smallest lights will always guide you home.
Welcome to the end of your world.
The storm brings the reckoning. We hold the war!
Alright, let's get into some LoRAs. First up, we have the transformation LoRA. It's sitting on some really solid positive reviews, and it comes in at 800 megabytes. Down below on the page, you can spot the prompting template alongside a working example. Looking at the template, you start off with the initial action and the starting clothes. Next, you drop in the transition movement, followed closely by the target outfit and the specific features you're trying to generate. Simply kick off your prompt with the phrase, Henshin transformation. After that, mention the initial outfit and action, follow it with the transition movement, and finish up with the outfit the subject is transforming into. Check out these example generations to see it in action.
Time's a heavy pour, isn't it? Ignite the engine within! Built to last, destined to lead.
This is where Scarface roamed. Respect the circle! I am the queen of Masai Mara. Resistance is a fragile weave. Rewrite the paradigm. Behold the crystalline future.
Now, let's look at a live generation process. For this, I'm using the 24GB FP8 version paired with Sage Attention 2.2. If you're worried about your hardware choking, here's exactly when offloading happens. Right when we switch the text encoder over to the LTX 2.3 FP8 version. But watch this. The very moment the sampling process kicks off, you'll notice a massive, sudden drop in SSD usage. As you can see right here, during the actual sampling, it's only the VRAM and your system RAM pulling the heavy duty, keeping the whole process butter smooth and stable. Now, you'll pull off very similar results if you're rocking an Ada Lovelace or a Blackwell GPU, simply because these FP8 models are practically built for them, dramatically speeding up the workflow while slashing those memory requirements. Another massive perk here is that Sage Attention fully supports FP8s, so when you combine the two together, your generation times get a serious speed boost, and memory demands drop even further. However, if you're running an older generation graphics card, honestly, your best bet is just to stick with the trusty, stable GGUFs. Your generation times will take a hit, but the visual quality of the Q5KM GGUF is pretty much identical to the FP8 version. Notice here that our generation times ticked up a bit, but that's just because we threw a LoRA into the mix. Alright, moving on to our next LoRA, and this one is actually one of the most heavily downloaded LTX 2.3 LoRAs right now. The model page gives you all the details you need, including the best use cases, and right over here is your trigger word. The creator even threw in a handy prompting guide to help you squeeze out the best possible results. Scroll down a bit, and you've got your template right next to an example prompt. Here we have 6 different example generations complete with their prompts, giving you a crystal clear idea of what this LoRA is actually capable of. Let me quickly show you what this exact transition looks like without the LoRA applied. And here is another quick example. Now, there are a ton of other LoRAs floating around, like the video reasoning LoRA, but to be completely honest with you guys, I just couldn't get consistent, decent results with it. But feel free to experiment with them yourself, as they easily slot right into this workflow. I've left links here to all the models, including these LoRAs, so just make sure to drop them straight into your ComfyUI LoRAs folder. Here is where you add and select your LoRAs, and you can easily toggle them on or off just by clicking these switches. If you ever need to get rid of one, just right-click on the node and hit the Remove option. Moving over to the video settings, this is where you dial in your resolution, length, and frame rate. Now this next part is crucial. The frame rate values you set right here absolutely need to match the frame rate value inside your video combine node. With certain LoRAs, or if you're stacking multiple LoRAs together, you might suddenly hit an out-of-memory error when generating 1080p clips if your length is maxed at 241. I actually ran into this exact wall with the transition LoRA. My quick fix was dropping the frame rate to 22 and pulling the length down to 221, which totally resolved the crash. Getting a clip this long at 1080p on an 8GB card is possible thanks to the chunk feed forward node, so whatever you do, make sure that stays enabled. I'm not going to deep dive into every single node and setting here, simply because I already broke down all those finer details in my last video. This video acts as a direct follow-up to that one, so definitely go give it a watch if you're looking for those deep, technical explanations. If you found this workflow guide helpful, please smash that thumbs up and drop a comment down below. Thanks so much for watching, and I'll catch you guys in the next video.